Hey, how's it going, class? Welcome to day one of actual geometry. Kind of a brief intro. What is geometry? Geometry, in and of itself, is today viewed as simply being about shapes. That's not really what it is. Geometry is the logical arguing of how some rules about shapes create all rules about shapes. Geometry is really a kind of turning point in math where you kind of go from this, trust me, bro, I'm a math teacher, kind of philosophy where you just have to trust me that I know what's going on, that I am telling you the truth, that when I tell you to use PEMDAS, that I'm right, that when we simplify, we use PEMDAS, when we solve, we use SADMAP. You just have to trust me that it's true. Because the proof of why we do that, why we do the things the way we do, that's a higher level thing. That's something you do in college mathematics. Whereas geometry is where we kind of start to introduce this idea of prove it. You should know exactly why you're right. You should be able to argue for why you are correct. And that's kind of the goal of geometry, is stepping into the idea of you should know why. Are we going to get into it a ton? Not really. We don't get to go into my favorite part of geometry, which is the proofs, which is the formalization of those arguments. I think that's what is the most important about geometry, because when we look at great historical figures like Abraham Lincoln, was a huge geometry person, because geometry is really based on this textbook called The Elements by Euclid. This is one of the most famous books in history. I want to say, top of my head, it is just after the Bible in terms of copies printed. That this is a hugely popular book. And The Elements is essentially, Euclid starts off with 27 axioms or fundamental beliefs. And from that, takes and builds, kind of like if you had 27 different kinds of Lego, puts them all together into random things. I want to say it's 485 theorems or fundamental rules about geometry from that. It's about arguing. And that's why Abraham Lincoln liked it so much, is because it was, how do you make a good argument? Well, you start with some fundamental truths, you put them together, and you create new truths that you build on, and that's how he wrote his speeches. It's why they're great speeches, and you should definitely look into anything about Abraham Lincoln. He was an awesome president. But that's what geometry is. So what we're doing right now is we're starting with a very small part, but in the end, we're going to basically do the fingernails of geometry. We're looking at just a very small part of it. We're looking at kind of like it catches your eye first, but you're missing the essence of it. I'm going to try to get a little bit of that essence in here. So one of the first things we're going to be doing is transformations, which requires that you are really good at graphing points. You need to understand how points work. So you want to remember these are x, y points. We go in the x, then the y when we're graphing. So pause the video right now and you can graph this. I'm just going to continue going, hit play, and you can follow along here in a moment. All right, so our first point here is over 3 up 7. I'm going to make these points nice and big because I know they're kind of spaced apart. Negative 3, 7. 3, 0. Negative 6, 2. And as you're working on this, you'll know if you're right or not. If you're right, it should make you happy when you see the result. Otherwise, maybe you're getting a little too abstract. Kind of like some of the good painters of the past. Like you might be kind of Picasso if your graph is not correct. And if you got any of those jokes as I was going along, then you're probably graphing this correctly. That what you should have here is a nice smiley face. So if you got a graph that looks like this, awesome. You're in a great position. You're probably going to do great. If you didn't, if you got a little Picasso here and this does not look like a face, make sure, come talk to me. It won't take very long to get you squared away to where you can do this, but we want to solve this early because this entire first unit is just graphing. In fact, the test for this unit is an entire page of just a graph where you're going to graph 8 different shapes. So you want to be really good at it. So if you already talked to me, you should have the note sheet. Otherwise, kind of just take notes on this. You can come in, get the homework, and fill in the information from your notes. But today we're talking about transformations, which transformations is any manipulation why are you switching pages? Any manipulation of an object. And we'll go into some of the different transformations, but the key one we're talking about today is translations, which I like to think of as push or pull. We're not turning an object, we're not flipping it, we're not making it bigger, we're not making it smaller, we're just moving it around. So, vocab, some keywords we need. We need to talk about what does it mean to be congruent. Well, to be congruent means that all that does not show up very well. All sides and angles are equal. So if we have two things, they are congruent if essentially what you did is you just copied and pasted, that these two things are clearly identical because everything about them is the same. That's what tells us if two things are congruent. Then we have what is known as the pre-image and the image. You are hopefully noticing that they both have the word image, so they're related. Now ask yourself, which one of those do you think comes first? You are hopefully noticing the word pre here in the pre-image. The pre-image comes first. The pre-image is the original shape. And by original shape, we mean whatever the object is and where it's at. The location matters. And that when we're talking about this, when we talk about shape, we're not necessarily talking about like, oh, you have a square and you do some sort of translation and magically it's a triangle. That's not how this works. If you start with a square, you're always going to end with a square. But as we're going through this, you have a square that's here. Well, you translate it, now it's here. Or some of the other operations we'll do, maybe you'll take this square and all of a sudden now you've got a bigger square. You have different kinds of transformations. The image is the transformed shape. Whether we changed the size, whether we just moved it to a different location, this is the one that is second. This is where we start, and this is where we finish after we're told a particular action. A transformation, if the length and angles stay the same, that is what we call a rigid motion. If from start to finish we maintain the size, if the two shapes are congruent, that is a rigid motion. That is a lot of what we're going to do. We're going to do a few non-rigid motions, but those are the key ones. So as we're looking at this thing, this activity, obviously, you're welcome to take and play the thumbs up, thumbs down game if you want. But I'm going to show you two shapes. Decide, do you think they're congruent or not? Are these two triangles congruent? Yes or no? The answer is yes. Because if you're looking at these, they look like they're the exact same shape. They're the same size. Everything about them is the same. And in fact, if I were to take and trace this one, I can take it and move it over here. And that works. And you can see that they're exactly the same size. Everything about them is the same. They line up perfectly. So that is kind of what we mean when we're talking about congruent shapes. Next up, how about these two? Are these two congruent? Well, hopefully you're seeing, no, they are not. These are very clearly, this one's way longer than this one. This one's taller even than this one is. There's nothing about these two that is congruent. And the last one, how about these two? These two pentagons. So this one might be a little trickier for you. If we take and try to outline this, I get an approximate shape. It doesn't have to be perfect. If I take this thing, already looking at it, it looks pretty close. Now I'm going to try to rotate it without changing its size, which I think I'm failing at miserably. But we can see more or less these are the same size. If I could actually grab the object and turn it, you would see they're identical. I did this in class, but here I kind of have to use the technology I've got. So you can see that yes, these are the same size. So that's kind of the idea of are shapes congruent. We're going to take a look at a couple of examples. I'm going to walk through it. Feel free. You can pause it anytime if you want to kind of give a problem a shot on your own, then check it against what I'm doing. Feel free. So are the two shapes congruent? Is our pre-image here triangle ABC, is it congruent to triangle A prime, B prime, C prime? The answer is yes. And we can logic our way through this. We can kind of look at it and say, okay, first off, yes, these things look very similar. All the sizes seem the same. But we're a little smarter than that. We can think a little harder. Now when I look at this side length here, let me see. Sorry, I'm trying to figure out a way to get this thing. It keeps moving around. This side length here is 1, 2, 3, 4. This side length is 1, 2, 3, 4. So I have two side lengths that are equal. Then, maybe you remember the Pythagorean theorem, maybe you don't. But we can kind of use that and think about, well, here, this side, I don't know this distance, but I can see that it is attached to a triangle that is a 3 by 3. That I can kind of see that if I were to do this, that to get that side, I have a 3 by 3 triangle. And if I come over here, I have a 3 by 3 triangle. And I don't know what this measure here is. Let me call it A. Let me zoom this in so you can see it even better. Now I can do the same thing over here. I can see that this is a 1 by 3 and a 1 by 3. That I can see that these two triangles, all the information about them is the same. And they have these very obvious, what we call corresponding parts. that relate to each other. As the year goes on, we're gonna get into this even more. We're gonna talk about this idea of, well, how do we know two things are congruent? Because right here, we're given everything about these triangles. But we're slowly gonna get to the idea of, well, how much of that information can I take away? What is the least amount of information I can give you where you can still tell me these two things are congruent? But that's coming later. For now, we can simply say that yes, I believe they're congruent. Now, the order I like to do these problems in is I like to look at it, go 1, 2, 3, 4. Because I find for me, that's the way that makes the most sense to me. So looking at this one, I'm already given these coordinates. I don't have to find them. I don't have to do anything to them. It's already done for me. So now I'm going to go to the rule. I'm going to think about, okay, I have A. It's the point -1, 2. And somehow I need that to become A prime, which is the point 6, 2. I would recommend pause the video and think about this. How do I take this point here and make it this one? So hopefully you've thought about this. Hopefully you have an answer. And part of this is that you should be coming up with hypotheses. You should have this is what I believe and this is why I believe it. So when I'm looking at this, well, I notice that here, my y values don't change. My y value is staying the same, but I need to somehow go from -1 to 6. And how do I do that? How do I go from -1 to 6? Well, I can take and I can add 7. If I add 7, I get the value I'm looking for. I go from -1 to +6. So I would write a rule. And we can see kind of the rule format here. I'm going to write it a little bigger. It's going to be something like x comma y becomes x plus 7 comma y. And this is how we take and we go from this coordinate to this coordinate. Now, this though is just my first guess. This could be wrong. In order to know that it's not, I need to plug in the other points. I need to check it. And you should do this for every single point. If I have the point B is 3, 2, well, if I plug it into this formula, what that's telling me is B prime is going to be the point 3 plus 7, comma 2, which means that B prime is the point 10, 2. Is this my B value? Yes. So it's checking out so far, but I need to check every single point. I've got the point C is 2, -1. That is going to become C prime. I get 2 plus 7, comma 2. Whoops, sorry, -1. I looked up here for a second, got distracted. 2 plus 7, comma -1, which is C prime is 9, -1, which is in fact exactly what I want. So this rule works. I'm good. I can move on from there. So then when we're looking at this, describe the transformation in words. My opinion is you want to make this as easy as you can. You want to just kind of think about this in the correct terminology. So the way I like to write this is say triangle ABC is translated how many units? Well, I'm moving 7 units in the X direction. So I would say ABC is translated 7 units in the X direction. And that would be my answer. That would be that verbal description is something like this. Now you're going to be really consistent. My opinion is you want to make this as easy as possible. This is what's going to change. The number and the X or Y here. Otherwise, you should have very similar things, and I guess this is going to change based on context. Whether you're talking about triangle ABC, whether you're talking about quadrilateral ABCD, whatever it is, you're going to change that. But for the most part, a lot of this stays exactly the same because we want some consistency of language. So at this point, you are free. If you're like, hey, I think I've got an idea, you can move on. I'm going to just work through, put the answers on the screen, and you can double check as you finish. So here, looking at it, yes, these are in fact congruent. I can just find these coordinate points. A prime is negative 1, 1, 2, 3, 4, 5, 6. So negative 1, negative 6. B prime is the point 3, negative 6. And C prime is the point negative 2, negative 9. Some things to note. When you're writing these points, you should have it every single time. You better have the parentheses. Without the parentheses, you're just listing two numbers. It is not meaningful. Another thing to kind of pay attention to is as you're labeling these, you want to make sure that you either have the A prime, B prime, C prime, labeling it, or even better is add those points in. I would say that this is A prime is the point negative 1, negative 6. B prime is 3, negative 6. C prime, negative 2, negative 9. It just makes our paper look a little bit prettier. Also, when we're graphing, if we have the pre-image to the image, the pre-image is going to be like point A. The image is A prime. We read this as prime. If you're doing one transformation, you're going to have A prime. If you keep going, you would have A double prime, A triple prime, 4 prime, and we kind of switch over to Roman numerals here. You can keep going indefinitely, up to you where you stop. Personally, I will not make you do more than 8 at any point during this year, so keep that in mind. So then I need to come down here and I need to make a rule. So I've got A is negative 1, 2, and that needs to become A prime, which is negative 1, negative 6. Well, looking at it, I think it's pretty fair to say the rule must be xy becomes, and my x stays the same. I think I'm going to be manipulating the y. And I need to ask, well, how do I take 2 and make it negative 6? Go ahead, think about that for a second. And clearly, I need to subtract 8. This, I think, is my rule. I need to double check it. So b is 3, comma 2. If I use this rule, b prime says it should be 3, comma 2 minus 8. B prime is 3, negative 6. Yes, it is. Let's do C. C is 2, negative 1. C prime is 2, comma negative 1 minus 8. C prime is 2, negative 9. As I'm looking at this. Now, can you spot what is the mistake I made? What error did I make? Pause the video and take and highlight it. And you can write, ha ha ha, Mr. Curry's an idiot. Whatever kind of helps it stick in your brain, because you want to pay attention to what are the mistakes that I'm making so that hopefully you don't make them. Hopefully you noticed I added a negative here. That should not be negative because this point is over here. What I had written here, negative 2, negative 9, would be over here. and it's not a part of the point. So good. At this point, we can see, okay, I've got a rule that works. So that's good. So now I get to take and make my sentence. Once again, remember I said, so we've got triangle ABC is translated. Here I'm going -8 units in the y direction. And I guess maybe for consistency's sake, what I wrote earlier, I would say this, and I would change those colors to triangle ABC is translated -8 units in the y direction. So hopefully at this point, you're kind of starting to get the feel for it and feeling better about it. Let's take a look at one more example. I'm going to kind of get you started on it, and I'm going to leave you to it to finish the rest of the assignment. Are they congruent? Yes, we've been dealing with the same triangles this entire time. We're just moving them differently. If the answer was no, if we said no here, we can't do the rest of it. The rest of this assignment is stupid if it's no, because you can't do anything. So keep that in mind as you're working through these. So then we can come in, we can find our points here. I've got 4, 8, 8, 8, and 7, 5. I can get my coordinates and kind of just pay attention to notice that, like, for going from B to B prime, I'm going over 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6. That I'm not just moving in one direction, that I'm moving in two directions at once here. And that's important, and that's kind of the cool thing is, well, what if I start stacking these rules? Because we already talked about, well, what do I do if it's a change in the x direction? Well, my rule is going to look like this. X, y becomes x, well, I'm going 5 in the positive direction. Y, I'm also going in the positive direction. So our rule becomes really easy once we see the other two rules on the last two problems. This one, we're just stacking it together. And we do that to all the points. And we just, here we have that, well, triangle ABC is translated, in this case, 5 units in the x direction and 6 units in the y direction. And I say both of them. Now, kind of just teasing out some of the fun places you could go with this. Where we go eventually in math is, well, what if I don't want to deal with this movement of going over 5, up 6? Because let's say I'm walking this. If this is a treasure map, like here, my blue path is 11 units. Which, depending on what you're measuring, if it's 11 meters, that's not terrible. It's like 30 feet. That's like walking across my room. It's not that far. But let's say that all of a sudden now you're talking about miles. Like 11 miles is far. I've started walking a 5K a day for the most part with my fiance. That's 3 miles. That takes us an hour. That's a lot of work. So 11 miles is a lot. So what we do in higher level math is we ask the question of, well, can I do this easier? Can I be lazy? And is there a way that I can figure out this distance here. What if I were to cut? Let me make this a brighter color actually. What if and let's go bright. What if I were to go here instead? What if I were to just go directly to the point? And that is what we call a vector. And eventually what we want to know is, well, if I know the distance here, which would be the square root of 61, which is like 7.9 units. If I know the distance and the angle, I can just go straight to it. And we'd want that because, well, that's a difference of 3 units, or in this case, if we're talking about miles, that's 3 miles, which 3 miles is about 1 hour. So like, if you can do this math, you can save yourself some time. And that's the goal. That's why we want to know this stuff. But that's a little bit further than what we're going to do. So don't worry about that if you are like completely lost when I started talking about that. Make sure, finish this homework up. You got a couple more questions. This one, you're given the rule, and you need to take this pre-image and make the image, find the coordinate points, and describe it in words. If you have any questions, please come in and ask them. I would love to help you get this. It's only going to get harder. It's not going to get too much harder this first unit, but it's going to get harder. So make sure that if you're confused, come in earlier. Don't wait until it's convenient. Make the time. This is important stuff. It's important that you learn it so that you can pass. If you have any questions, please come in and ask. I will see you next class, hopefully. If you're not feeling well and that's why you're watching these videos, I hope you feel better. If you're just watching them because, hey, they might be helpful and you just need to hear it again, congratulations, you're making huge strides towards your education career. Have a great night.